it can be driven either with hydrogen or with gasoline.
And in the future, near future, around 2015, Toyota is going to introduce fuel cell electric vehicle, which is used hydrogen as an energy and convert it to electricity.
Suggested we're going to have a provocative session because after lunch we tend to nod off. So, starting with provocation, I've broken the stand. We've got a panel of Darryl Wilson, David Hart and Klaus Bonhoff. I'll let them each introduce themselves and give you a little background as to their interest in this sector, and then we'll move to Klaus to outline what the Germans are actually doing for those who don't know. David.
Good afternoon. I'm Darryl Wilson, President and CEO of Hydrogenics. We're a Canadian-based hydrogen technology company. We have offices in Belgium and Germany, and we've been very active in the German market and benefit from much of the leadership in Germany in this area. It's good to be with you this afternoon.
Fuel somewhere around the year 2000. That was when automotive companies announced commercialization of fuel cell vehicles, which then did not materialize for various reasons. We then went through a hype on biofuels. We just went through a hype of batteries. We're now probably approaching a hype on gas, natural gas that is, possibly biogas. I think what we've learned by now is that if we look at sustainable mobility solutions, it's not the solution, but it will be a portfolio of different technologies and fuels that we're looking at. But coming back to hydrogen, around about that year 2000, one of the analyses did show that yes, ultimately, if you take efficiency, CO2 emissions, and introducing renewables into the fuel sector seriously, hydrogen is one of the best options you can choose. But we don't have hydrogen introduced as a commercial fuel. We have hydrogen around for over 100 years in the chemical industry. It's a commodity in that sector. €1 billion, half of that being publicly funded by the Ministry of Transportation and the Ministry of Economic Affairs, and the other half being funded via industry. To go into this 10-year program to do market preparation for hydrogen fuel cells, not only in transportation, but half of it being dedicated to the transportation sector, also looking at fuel cell technologies in the stationary field. Düsseldorf, Cologne area, Stuttgart. We're still hoping that Bavaria is waking up soon. We have hydrogen infrastructure in place in these metropolitan areas as part, again, of demonstration activities, not as part of commercial activities. But we're very successfully testing these technologies, and we not only look into the technology, we also look into customer acceptance, safety, regulation codes and standards, and these kind of activities. In the energy system, or transitioning of the energy system, which not only means that yes, there seems to be a public consensus at this point in time to fade out nuclear power by 2022, but which also, and more importantly, includes that we all understand that we have to increase the share of renewable energies in our power sector, that we have to do everything we can do to increase the efficiency of our energy system. And if you look at the increase of renewables in the stationary power sector, and you understand that these energies are fluctuating energies, the wind comes and goes, the sun comes and goes, storage becomes a very important topic to be looked at, and this is being discussed very intensively. And again, same as talking about sustainable mobility. If you talk about storage, there is a portfolio of solutions out there, and there's not the solution. But if you do start to look into the amounts of energy you will have to save over time, store over time, just to make sure that the energy that's being produced in windmills and photovoltaic areas is not being wasted because it cannot be taken by the grid at that point in time. If you look at those amounts, and if you consider that you need seasonal storage to cover wintertime, summertime effects, you will end up with an answer that hydrogen has to play a major role in that. So all of a sudden we're discussing hydrogen as a storage media in the context of fulfilling our goals around the Energiewende. $1 billion in order, to provide energy to the transportation sector, possibly not. But then if you really boil it down to the initial risk phase, you get to completely different figures. The first few hundred of stations, they're loss-making because they're underutilized, because you still need to de-risk the technology. So all of a sudden you're talking about, for the next 5 or 10 years, about an investment of a few hundreds of millions of euros, divided by a few large companies, maybe some government support in that. So all of a sudden you talk about a picture that is very, very doable. And making or creating money in the market, at least that's my understanding as an engineer, is not too difficult if you can show that longer term there is a viable business case behind that. Plus the opportunity you have to not only sell fuel to the transportation market, but to also serve as a storage media, really making sure that building up your capacity on renewables is doable.
Society, billions and billions. Big power is dumped in Poland in the ground because it cannot dump it in Germany. It cannot be used somewhere else. So my concern is that if the law changes, and it would be very easy to say no priority over renewables, and I see utility companies lobbying at government level doing that.
I think there are 3 key points to address. One is that actually the regulatory driver for transport is not particularly about utilising spilled renewables. It's about reducing CO2 emissions in the long term, which you can also do using natural gas for some considerable period of time. Natural gas to hydrogen is very cost effective, and if you have to do that, because as you say, something changes in the regulation, you can still put in an infrastructure, drive down costs, and set the scene for renewables. And I know we would, particularly Darryl, would rather have the electrolysis solution with open spilled renewables, but in a pragmatic sense, there is a second option. And there are 2 other things. One is that, again, this is one aspect of the market. There are companies' iteration of design work, and there are some partnerships which are very important, not least with Shanghai Automotive, GM, and others. But it is not obvious that China is going to be the place where fuel cells are manufactured in the near term. Some of the componentry may be, some membrane manufacturing facilities in China will ultimately be able to undercut facilities that are currently in other jurisdictions. But certainly in the near term, the high value parts of fuel cells are likely to be manufactured in slightly more expensive and slightly less risky jurisdictions.
To me, the reality is that the large OEMs never discontinues their development. This is why we are where we are today. Hydrogen stations by 2015 in Germany, which is still part of the R&D program that we're funding. So the German government says we need to continue to improve the technology, but at the same time, those 50 stations are located throughout Germany in a way that you can actually travel from east to west, from north to south, focusing on the metropolitan areas, but including corridor stations. And the proposal that was put forward by the European Commission just 2 or 3 weeks ago actually has the spirit of how do we make sure that throughout Europe, along the major transit ways, we have hydrogen available. So that's their political motivation to make sure that Europe as a market for this technology is available. And if we look into the fact that Toyota, Hyundai, Honda are all participating in our German program with vehicles in Germany, they do that because Germany at this point in time is one of the few places in the world where 70 megapascal public fueling stations are available. Not a lot, could be more, but hey, they are available.
You mentioned the range extender concept, which I understood was what the automotive manufacturers preferred to address the range anxiety point. Surely consumers are much more comfortable and are familiar with buying gasoline, and it could be priced at a very high level for those that demanded the comfort of having a car with a range extender.
Applications such as GSM relay towers,
on isolated sites. So there's a real role here for hydrogen, utility and for industrial applications away from transportation. What do we do with surplus energy when we're generating it, and how can we best capitalise on that? So a quick thoughts across the panel, I think.
So absolutely, the largest hydrogen fueling station in Germany was opened, in Europe, sorry, was opened in February last year in Hamburg. It's an electrolyzer built by our company. It's owned and operated by a utility, Vattenfall. We're in the process of starting another station in Stuttgart owned by a utility, BMW. So this connection between renewable infrastructure, fueling, and vehicles is already being realized with the commercial eye of utilities in Germany, so absolutely. My last comment to affirm the proposition in front of us, I think the juggernaut of Germany has not just led here, but also in solar and also in wind, and Klaus was perhaps a little bashful. When you look at the coordinated effort between the German research institutes, organizations like his, from a program management point of view, a coherent thinking and strategy from the government, in close collaboration with industry, it's very hard to find another place in the world where energy technology has been thoughtfully moved ahead, as I say, in wind, in solar, and now also in hydrogen. And it's created a wonderful opportunity, I think, for Germany, but they've done it with an open-handedness. We know of other nations around the world where there has been a closed mentality, a protectionist mentality, and as a Canadian company with operations in Germany, we feel free to do business, we win projects, and we feel the opportunity to participate with their leadership, which I think is a very, very positive thing.
I wanted to say just a couple of things. One is that picking up on that last point, there are definitely applications which are outside transport, and the interesting thing which I've seen in sort of 20 years in hydrogen is that when I came into this, to some extent it was an elegant, physical, ideological, purist solution which was propounded as the hydrogen economy will save the world. And now it is much more a demand-side, pull-driven, technologically appropriate, industry, finance, business than it ever used to be. And that is a fantastic sea change. And I would love to be contrary, but unfortunately I have to agree with Daryl and say that part of this is due to Germany. Germany has had this very, I think, appropriate, very structured approach to pulling this through. They have a very strong industrial base, a very strong research base. Clearly they're doing it partly to ensure that persists. And of course there could be more money, things could happen quicker, all sorts of things. But I think they've done great things. It's right for Germany. It wouldn't necessarily be right for some other countries, but I think they've got it absolutely right for what they need to do.
Let's add to that, and wouldn't talk about that in more detail. The solution is in an optimized overall system approach, including the power sector, the transportation sector, energy solutions for industry. We have an opportunity to fill those gaps, to fill the links in between different industry sectors, different policy frameworks. I think this is what we need to work on, and this is what we've started to do with a solid R&D base, which not only included fundamental R&D, but which was looking explicitly at demonstration, large-scale demonstration, real-world demonstration, making sure we do not only develop the technology, but we look at the customer, we look at the policy framework. So this cooperation is, I think, what's really driving that's the driving spirit of the discussions that we have in Germany.
This whole sector probably, it's fair to say, was birthed in Canada, where I come from, but not so long. Some years ago, we would readily concede the leadership in the sector to Germany and the things that they have done. One of the things that German friends do very well is study things deeply from an engineering point of view, and there are several studies that have been conducted. Perhaps the one I'll refer to is called the Portfolio of Powertrains for Europe. Germany was a very active part of that, as well as other European countries. The various powertrains that are available to us for automotive vehicle design, and the automotive OEMs believe that hydrogen technology will offer that range autonomy, which has become the expectation of vehicle owners. So it's primarily driven by range, is where the edge is.
From an economic point of view, the data was studied very carefully, considering infrastructure and the vehicle itself.
If you have renewable electricity and you can use it at that moment, go for it. Absolutely. There is no point in turning it into something else, losing efficiency on the way, turning it back again. So, in the simplest sense, if you can use it when you make it, yes, please do. Unfortunately, as Klaus alluded to, you can't always use the renewable electricity that you have, and therefore it's better to turn it into something which you can store. Storing electricity is terribly difficult. You actually have to store something else. You store potential energy, you store chemical energy, you store all sorts of different things. So hydrogen is one option for doing that, which gives you the opportunity for very efficient, clean-burning fuel, and also for arbitrage, because, again, you can use this potentially in transport, potentially in stationary applications, potentially in chemicals.
He's the hydrogen man, and we're developing a marine combustion engine, which will hopefully be shown in Monaco next year on the tenders. And this design here, for the larger versions, we're looking to put the fuel cells for the auxiliary systems within that. If you wanted hydrogen within that boat, we can fit these hydrogen fuel cells as an auxiliary power source for the auxiliary system.
The company provides flexible, three-dimensional waterproofing solution.
Not enough for us innovation. The main stronghold is hydrogen energy. We are convinced, and we've already patented technology that hydrogen propulsion is possible in the shipping industry. First with small tender boats, then with 32 meter yachts, eventually at the end with 50, 60, 70 meter yachts. One crucial point is that it is zero emission. Totally zero emission, not neutral emission, it is zero emission, because the hydrogen can also be produced by green energy like wind and solar, and the combination of wind and solar to produce the hydrogen and then use the hydrogen on the boat is totally zero neutral.
They had to mobilize massive numbers of workers. They had to create craft skills and differentiated labor. They had to manage the storage bins and the distribution. It required a new communication revolution to organize agriculture, and it was called cuneiform writing. Everywhere hydraulic agriculture originated, in the Middle East, China, India, and Mexico, with the exception of Peru, independently, human beings created writing to manage agriculture. Communication and energy revolution. We store them with hydrogen, which is a carrier, so you can use it for transport, but convert it back to electricity. It is like digital. It's a universal storage carrier. Then what do we do with the surplus energy we don't need in our homes, office, factories? This is where the distributed communication revolution converges with distributed energy. Millions and millions and millions of buildings loading all the energy that's distributed across the planet, storing it in the form of hydrogen, which is like digital, a universal carrier, and then moving it to each other across smart power grids. That power, my friends, is far more than we could ever have gotten with the most powerful coal-fired power plants or nuclear power plants or oil-fired power plants in the world. Build the juvenile infrastructure. By 2020, 2025, we'll have a juvenile infrastructure in place. If we are on mission here, by 2035 or 40, we should have a mature infrastructure in place.